The first is a definition. I will talk about definition, what is the refrigerant itself. So, and then we go to next session, history. And then the third one is classification of refrigerant. And then color, coding, and then properties, and we will close by the conclusion, right? Okay, we go first in the definition. Refrigerant acts as a transportation medium to move heat absorbed in the evaporator to the condenser where it's rejected. So it has low boiling point compared to the water. Actually, yes, because it's easy to the transport the temperature, right? Okay. One of medium we need to transport of the temperature is a refrigerant in the refrigeration system, because without the refrigerant we cannot transport the temperature within the low to the from the high to the low temperature in a certain of main area or the device. Okay? As an example is refrigerator, fridge. So how about that boiling compared to water? Also should be lower the water, because it's, if high to water is very difficult to transport the temperature, right? Okay, in early development of refrigeration, we will they actually implement the natural of refrigeration, such as the S block, using the nocturnal cooling and use of evaporation method. Before I already explained how to the from the food container to keep the quality of the food, like maybe from the plantation, we can get some of the food, and then we try to keep it, like the what we call whole, and then the milk. They use this method to keep the quality of the food, but still have the some of the limitation of natural refrigeration, such as depend on the local condition and weather, and difficult to produce large amount of refrigeration. So if we compare night and day, so extremely different, because of the in sunny day it's difficult to get the low temperature. So this one is already live in the some of refrigerator system, but some we can for chiller, we can still use of natural refrigeration. Okay, from history, in 1835, Jacob Perkins used ethyl ether as the refrigerant, and then the 1874 Royal Pellet designed the first sulfur dioxide. And then we go to 1885, France Wilhelmsen built the first to use the CO2, carbon dioxide, in Germany. And then 1920, was using isobutane based on domestic refrigerator. And the last is 1930, introduced CFC. Okay, this one is a type of the history of a type of refrigeration. Okay, we go for the refrigerant currently used in emerging countries. HCFSC 22, and then R410, and then go to HFC 32, and then and so on until to refrigeration to 190. This one is history that used already in the commercial of refrigeration system. Then we can check inside the graph. This mean comparison within the economic performance, safety, and then energy efficiency. Okay, the most uh, in ideal condition, almost ideal condition where we need in the refrigerator is dominated by HFC 32. It's very good to us. Then we go to type of refrigeration based on the working principle. We have to type primary refrigerant, secondary refrigerant. What is the primary refrigerant? Is used directly as working fluid, undergo phase change, refrigerant of 134, and then refrigerant 404. A second refrigeration is liquid use transport energy, not undergo any phase change such as water, brines. So this one is primary refrigeration, is dominant in the commercialized refrigeration. Most of use or implement in the refrigeration is the type of primary refrigerant. Type of refrigerant based on the chemical property, pure fluids, yes, we divide by two types also, synthetic and natural. So what is the synthetic? With the CFC, HCFC, HFC, and the natural itself with the organic hydrocarbon, organic ammonia, carbon dioxide, water. Okay, based on the classified of high flammable and low flammable and no flammable propagation, the international safety give by the code with the no flame propagation by A1 with the low toxicity, and then the no flame propagation B1 is the higher toxicity. And then we go to the lower flammability A2 and A2L. But A2L itself is lower flammable refrigerant with maximum burning velocity is less than or equal 10 centimeter per second. And the high flammability should be higher than 10 centimeter per second. So is this one given by code A3 and B3. Okay, this one classification of the refrigeration type with the safety classification. Okay, you can see. So for example, ammonia with the safety disclassification B2. This means have high flammable and toxicity. Okay, if we see the A1, A1 is no flame propagation. See, such as water, carbon dioxide, and the high flammable, ethane, propan, isobutane. Okay, you can see from the table all the refrigeration with the safety classification. Now we go to the natural refrigeration, hydrocarbon, such as I mentioned before. The efficiency is good with the no ODP and very small growth WP values and compatible with the lubricating oils. Extraordinary reliability, high flammable. Okay, with the chemical name C2H6. Okay, CFC combination of carbon, chlorine and fluorine, you can see all uh, have good actually, good performance and safety. This one is already implemented in the refrigerator system. Okay, now we go to explain in deep in the natural refrigerants under the hydrocarbon classification. What the specification in the hydrocarbon? They have efficiency is good, and then with no ODP or very small global warming potential value, very low. So it's actually this is what we want in the our issue now in the global warming. And then compatible with lubricating oils. It's mean it's suitable in the certain compressor like the screw compressor. And then extraordinary reliability, and then highly flammable. In the chemical form is C2H6. And then what is the CFC? Combination of carbon, chlorine, and fluorine. So also commonly known as freon. So we call some freon. So maybe in the market, we just call the freon. High ODP, now we don't use it anymore. And the high global warming potential. Chlorine has an excellent anti-wear characteristic. Maybe certain compressor good when we apply the CFC's refrigerant. And then as ODP, ozone depletion, potential and global warming potential is high. So already got banned. R12, R11, and R13. So this one, the CFC group, you can see R11, 12, 13, and so on. Chemical name and the application. Then HCFCs, hydrogen, chlorine, and carbon. Low chlorine, this one is actually after we summary, and then we got item to classify what the good and the drawback of the HCFCs refrigerant itself. So content the CFCs. Chlorine, ODP, still have ODP, but less. Low global warming potential, really good. Not flammable. Okay, CFC. HCFC is good with the commercial name is R123. Sometimes sometimes only 123 only. Okay, this one the group of HCFCs. Chemical name and the application. Okay, this one is higher or extreme application, ice machine and so on. Okay, in the group FSS, CS, HFCS, hydrogen, fluorine, carbon, non-flammable, recycle, low toxicity, minimal emission, ODP also zero, low GWP, and require POE oil for the lubricant purpose. Okay, for example, this one, R410A. Okay, this one group in the HFCs. Okay. Okay, example, of application based on the type of refrigeration. Okay, you can see here, for example, carbon dioxide in the hydrogen fluorine carbon. You can see the application with a certain compressor, and also this one is type of the we call condenser. Yeah. Then another example, split aircon. We use the HFC. Okay, you can see by yourself from the slide, based on the application of the refrigeration to the type of the refrigerant. Selection criteria based on the thermodynamic and thermophysical properties, environmental and safety properties, and the last one is economic. Thermodynamic properties because based on these parameters, the first one, boiling point, freezing point, evaporative pressure, condensing pressure, latent heat over evaporation, critical pressure, temperature, thermal conductivity, and the coefficient performance. So when we go to first parameter, boiling points, it should have low boiling point. Yes, freezing point, it should have low freezing point. So it should be satisfies this parameter in the thermodynamic properties. That we go to thermal conductivity, it should have high thermal conductivity. So what the high thermal conductivity? If we transfer the temperature, we can transfer almost 100%. Yeah? This one we call thermal conductivity. So if we transfer 100 degrees Celsius, so we transfer, the medium can transfer 100, almost 100. Should be like that. Then coefficient performance, COP, has direct effect on running costs of refrigeration cycle. So higher to COP, lower will be the running cost. So COP is based on the differentiate between the low temperature to the high temperature. If we got the differentiate higher, it means COP is good. We rejected to the environment, the temperature is higher, but inside of the room is more lower, consider COP performance is good. And then we go to chemical properties, when we try to select the refrigerants to be in non-toxic, so we satisfies all these parameters. And then corrosive, with the not be corrosive, flammable, it should be not flammable, low flammable, at least miscibility with oil, should not react with the lubricant oil, chemical stability. So based on this parameter. And then physical, only three parameters should be measured. Specific volume should be low in vapor state, and then viscosity should be have low viscosity, and leakage detection. It should have less tendency to leak, and if it's leaking, it should have pungent smell, so that leakage can be detected easily. Okay, it should be fulfill all these items. Other properties, handling, maintenance should be easy, cost should be low, performance of the system should be good, or satisfied how powerful the performance. Ozone depletion should be effective to the ozone, because if effect to the ozone, we should be ban this refrigerant type. Okay, global warming potential also should be low, or maybe we should be try to the make a zero. And, yes, if we effect to global warming potential will be increase the temperature of the Earth. Okay, this one, the what we make a law in the refrigeration system should be through Montreal Protocol, yeah, signed in 1987. Okay, I think that's all for our class in the chapter 7 on the refrigeration system. Yeah, thank you. That's all.